Good afternoon, children. Today we'll just see about metallurgy. This is the next important topic. In this particular topic, we'll just see about, in the beginning, we'll be studying about the metals and non-metals. When you look into the introduction, metals and non-metals can be identified with the help of their electronic configuration. That is, 1, 2 and 3 electrons in the last shell means it's a metal. 4, 5, 6 and 7 means it's a non-metal. Chemical reactions taking place based on the number of electrons in the valence shell. We all know very well if it has 1, 2 or 3 electrons, it will tend to lose electrons. If it has 4, 5 and 6, 7 electrons, then it will tend to gain electrons. Okay, in case if it cannot gain or lose, what it will do, they both will share the electrons in order to attain stability. Modern chemists have found methods in order to extract metals because metals do not exist in free state. They extracted the metal using different methods, and they also improved the property of the metals by doing alloying. Very few metals are found in free state, and many of the other metals they exist only in its combined state. Properties of metals and non-metals. When you look into the properties of metals and non-metals, again, we'll just divide this into metals and non-metals. It will be a repetition, children, but still no other go. We have to study. Metals means 1, 2, 3 electrons in the last shell. 4, 5, 6 and 7 electrons in the last shell means it's a non-metal. When you take metals, they tend to lose electrons. When you take non-metals, they tend to gain electrons. So when they lose electrons, they become electropositive. When they gain electrons, they become electronegative. When you look at its valency, if it loses 1 electron, it's 1 plus. When it loses 2 electrons, it becomes 2 plus. When it loses 3 electrons, it becomes 3 plus. Valency of non-metal, same like that. Since it gains electrons, it will turn into minus. 1 minus, 2 minus and 3 minus. Properties of metals and non-metals, we have to see, children. That is lustrous. Metals we know. They are lustrous. High melting and boiling point. High density. Ductility and malleability. Now all these properties we already know. One thing what you have to keep in your mind is you are supposed to check which are the metals which do not possess this property. So exceptions only they will ask questions, children. So you have to go through the tabular column in the textbook. They are good conductors. Metals lose electrons and form cations. They are good reducing agents. Since it's a metal, when it combines with a chloride, it will form an electrovalent chloride. Yes, when you take oxides, you have two types of oxides here in metals, children. That is basic oxides, potassium oxide, sodium oxide, calcium oxide. When it reacts with water, what will happen? It will form a base. So the name has been given like that. What is it? It's a basic oxide. When you take amphoteric oxide, what do you mean by amphoteric oxide? Amphoteric oxide is one which will act as base as well as acid. Examples: aluminium oxide, lead oxide and zinc oxide. Next we'll see about the properties of non-metals, children. Non-metals usually they are not lustrous except graphite and iodine. It has low melting and boiling point, low density, and it's not ductile and it is not malleable except carbon fiber. Again I repeat, exceptions are very, very important. It's non or poor conductors. They tend to gain electrons to attain stability. Good oxidizing agent. Go through the properties of one, children. It will be the opposite for the other. Okay, keep that in your mind. Forms covalent chlorides because this is a non-metal. When non-metal combine with another non-metal, it forms a covalent bond. Acidic oxides. What do you mean by acidic oxides, children? Carbon dioxide, sulfur dioxide, nitrogen dioxide. These oxides, when it dissolves in water, it gives you carbonic acid, sulfurous acid, nitric acid. So, what does it produce? It produces acid. So, it will be termed as what is it? Acidic oxide. You have another category of oxide, what is called as neutral oxide. What do you mean by neutral oxide? Which is neutral. It, on dissolving in water, it is neither acidic nor basic. Example, carbon monoxide, nitrogen oxide, water. All these contain oxygen in it. It is an oxide, but it is neither acidic nor basic when dissolved in water. Next, I'll just show you all the periodic table, children. When you look into the periodic table, I've asked you all to remember the structure. Yes, just recollect the structure and I will explain briefly about that particular thing because we have studied in detail about the periodic table. First group, it's called as alkali metals. We all know very well they are called as alkali metals. Second group metals, elements are called as alkaline earth metals. 3 to 12, we call it as transition elements because they have transitional property. 13th group onwards, they are called as post-transition elements, that is present after the transition elements. 17th group elements are called as halogens. 18th group, zero group elements. 6th and 7th period of the periodic table is called as inner transition elements. Children, right from the beginning, right from first page, so far whatever I've taken, I've summarized and I've put it in the slide. So, keeping all these keywords in your mind, if you go through, more than enough for you all to score marks. Occurrence of metals. Now, when you look into the occurrence of metals, how do they occur? They do not occur in free state except gold and platinum. Only gold and platinum exist in free state. The reason is they do not react readily with any chemicals. Is that clear? When you take other metals, they usually exist in different forms. Different forms like oxides, sulfides, carbonates, halides or sulfates. Any form it can be. But it will be present only in its combined state. Now we have to see about the terms used in metallurgy. What are the terms used in metallurgy? Same like this, we have learned the terms used in electrolysis. Do you all remember all those terms? Okay, so throughout that particular lesson, we used all those terms. Same like that here also, throughout this lesson, we'll be using all these terms. I'll just explain to you all children, what is a mineral? The compound of various metals found in nature. A chemical compound, which is naturally obtained, will be called as a mineral. When you take ore, what is ore? See here, minerals from which the metals can be extracted profitably. For example, you take aluminium chloride, aluminium bromide, aluminium hydroxide, and aluminium oxide. From all these compounds, if you are going to extract aluminium, the amount of aluminium what we are going to get as a yield will be very, very less. So, one particular substance may give you more amount of yield. The yield may be more. So, the substance which gives you more yield when you do the extraction will be called as what is it? Ore. So, in that case for aluminium we use bauxite. Bauxite is the chief ore of aluminium. We don't go for aluminium chloride. We don't go for aluminium bromide. We don't go for any other salt. Aluminium salts. We just take bauxite because yield of aluminium is more in that. Next one is matrix. What do you mean by matrix, children? It's nothing but the earthen impurities. What do you mean by earthen impurities? It could be mud, sand, clay particles, okay, all dried plants, leaves and all those things. Okay, so that's called as what is it? Matrix. Next one is flux. What do you mean by flux? In order to remove all the sand, mud and various other earthen impurities, we can add some chemical component to remove those earthen particles. Okay, so that is called as what is it? Flux. After you add a chemical compound, you get one product in which that gives you, that is called as what is it? Slag. What do you mean by slag? The substance which is obtained after adding flux. That's called as slag. Now I'll just show you a few pictures, children, based on the common ores of aluminium, zinc and iron. In this slide, I have explained to you all, I've shown you all the picture of ores of aluminium. The fixed picture is called as bauxite. Okay, so this is bauxite. This is how bauxite will look. This is the chief ore of aluminium. The next chief ore of aluminium is cryolite. Okay, corundum picture is not able to get. So corundum is another chief ore of